With us now are Michael Lustgarten and Bill Faloon. Bill, always a pleasure to have you.
Thank you, Richard.
Sir,
Yes.
a pleasure to have you joining us. It is really very interesting to have all of this intellectual activity here. Please tell our audience what you're working on at the present time.
Sure. So I'm a scientist investigating the role of the gut microbiome and the serum metabolome and its association and potentially causative role on muscle mass and function in older adults. That's directly what I study, but I'm here to talk about other stuff too. So.
Well, you're talking about combating frailty, which is a huge problem as people grow older.
Yep.
They fall, they fracture, and often they don't survive that single fall.
Yep. So I actually didn't care about the role of bacteria and potentially in frailty. I identified a whole bunch of bacterial metabolites in older adults that had less function and less muscle mass. So wrote some grants, got them funded, and yeah, the hypothesis is there are specific bacterial populations that would be enriched in high-functioning people and potentially diminished in the low-functioning. So yeah, we're going to see what's going on there. And then to test causation, we're going to transplant the bacteria from the older adults into germ-free mice. And the expectation would be, yeah, the low-functioning older adults would end up, that phenotype would be transferred into the germ-free mice. Their function should get worse faster than the feces from the high-functioning older adults.
That's fascinating.
Yeah.
So much of this has to do with a concept we've talked about in this program many times, immune senescence.
For sure.
Whereas people age, their immune function declines, and unfortunately it transforms into a pro-inflammatory state. They have all kinds of inflammatory conditions and weakened immune function.
Right. So the inflammation is the danger signal that you're under chronic infectious stress. So the question is, what can you do to optimize your immune system? So for me, it starts in the gut. High fiber diet will feed your good gut bacteria to make the short chain fatty acids, which are fuel for the intestinal epithelial cells, which should keep stuff out of the blood that shouldn't be there, thereby reducing the amount of burden that your immune system should face.
This is most fascinating. Bill, tell our audience about the complementary research Life Extension is doing in the same field.
Well, what's happening is we're identifying mechanisms in which older people lose their immune function, and we've identified some potential therapies that can restore youthful immune competence so that the bacteria, the viruses that unfortunately accumulate in people as they grow older and kill them, if you restore immune function, you can lengthen lifespan and also health quality considerably. You can suppress the inflammatory factors that create so many miseries and chronic conditions. Alzheimer's, vascular diseases, they're all related to inflammation. And cancer, one of the most frightening ones, inflammation feeds it. So what we need to do with older people, and we're doing that through several different research projects, is to boost their ability to fight off the infections and the malignancies, and at the same time suppress the excess inflammation.
Dr. Lustgarten, what cooperation or lack thereof are you experiencing in this important research that you're conducting?
I wouldn't say there's a lack of cooperation at all. From my experience, it's ideas drive. You know, if you have an idea and it's properly, explained with data, the funding is there. So there isn't a lack of cooperation from what I've experienced, or even resistance to it. But I think this idea that immunosenescence, it feels like it's a secondary thing. Most people are not talking about this. It's, oh, we're going to die from heart disease or cancer, and what'll kill you faster than heart disease or cancer is an infection. You get a bad infection, you start fevering up, you can die the next day. Whereas heart disease will kill you for decades and cancer will kill you in a few months. So making sure the immune system is sound and strong is the utmost importance.
Well, that's what winds up killing older people. If nothing specific is a cause, it will be immune senescence. They'll die of pneumonia, septicemia. These are still leading causes of death, mainly in older people with compromised immune systems.
Now, you actually, in your research, decades of research, you've experienced some breakthroughs, but also lack of cooperation. Would you like to share that with our audience?
Well, there are a lot of scientific advances that are currently being suppressed because there's simply too much bureaucracy. And to design a clinical study requires FDA approval. that approval can take a long time, and it's a lot of money just to put together an investigational new drug application to do human clinical research. Now, Dr. Lustgarten is talking about, I believe, an animal study. Those are relatively easy to do. You don't need the government's approval to do rodent research, but we at Life Extension right now are pioneering human age reversal clinical studies, and that requires FDA approval. And one of the primary goals of that research, by the way, is to restore youthful immune function.
Doctor, you have written some books on this subject matter. Please share with our audience some details.
Sure. So over 110 years ago, the #1 cause of death was infectious related. Pneumonia, diphtheria, tuberculosis, and then various public health advancements, antibiotics, vaccinations. The mortality rate from infectious disease dropped dramatically to the point where it's almost completely forgotten. Right now, in 2010, 3% of all deaths were related to pneumonia or influenza, and it's completely forgotten. So we're focused on heart disease and cancer and these other major killers. But the fact is, cardiovascular disease patients have an increased circulating bacterial load compared to healthy controls. Bacteria found in the plaques of heart disease, people who have heart disease. So when you combine these two data, this suggests that we haven't won this war against infectious disease. We've just delayed it to the point where it's slowly, we are fighting them for long enough where then it leads to diseases like cardiovascular disease. Another one is Alzheimer's disease, where recently bacteria found in the plaques, the plaques that are causing inflammation, doing all the bad stuff in the brain. Not just bacteria, viruses, fungi, and then adding more support to the idea that things like age-related diseases like Alzheimer's disease are infectious related. The proteins that are found in these plaques have been shown to be antimicrobial, which suggests that the brain makes it as a protective mechanism against infection. So bacteria and microbes can be linked to insulin resistance, causing insulin resistance, whether directly or indirectly through their signaling pathways. They increase oxidative stress. They're related to faster telomere shortening, and they're well known to increase inflammation. So when you consider that infectious burden is related to 4 major theories of aging: insulin resistance, inflammation, oxidative stress, telomere shortening, and they're found in these age-related diseases, the book that I've written, the short book that I've written, gathers all this data to suggest the hypothesis that infectious burden is what's driving these phenotypes. It's what's driving aging. It's what's driving age-related disease. And then instead of treating the secondary effects, oh, well, you've got telomere shortening or elevated oxidative stress, we should be going after the primary thing, which goes back into the immunosenescence. Why isn't our immune system well enough and strong enough to fight these things off over time? And the fact is, we're so dramatically outnumbered by microbes, it's a losing battle. We have to be smarter than they are. We have to design therapies that are more efficient in killing them. So, and we've been doing that over the last 110 years. Our lifespan, since we've recognized infectious burden as a major driver of age-related disease, lifespan in the year 1900 was 30 years. And as we've delayed infectious burden, it's now well over 70. And I don't think that's a coincidence. So as we're better able to fight infectious burden, I think our lifespans will also increase in parallel.
What would you like to add to that, Bill?
Well, as Dr. Lustgarten mentioned, infectious disease is forgotten because it's mainly striking elderly people. They're suffering from it, and certainly middle-aged people are stricken also. But when the children were getting wiped out with bacterial infections, that was a horrific era in history, and that's pretty much taken care of. Children don't normally die of bacterial infections anymore, but the older people are. They're the forgotten ones. And we at Life Extension are recognizing the fact that to keep our supporters healthy, we have to maintain youthful immune function until better therapies are developed to rid the body of these excess bacteria. And I'm very familiar with the atherosclerosis and how bacteria gets into those lesions and creates coronary artery occlusion and stroke, all kind of major problems. They're just overlooked.
Yep.
There seems to be accelerating progress taking place in medical research. How do you see the future?
Right. So eventually, I'm actually with Aubrey de Grey on this. It's the escape velocity in terms of aging research. So our rate of aging is pretty constant. Unless you have a pretty terrible diet, it can get a little faster. But our progress in understanding aging is incrementally increasing. And eventually there will come a time where what we know about the aging process is exactly matched with how fast we age. And when that process happens, technically there's no aging. But we aren't going to just get to where we understand aging. We're going to get to the point where we understand it comprehensively, where, aging is a minimal thing. It's a thing of the past. So that's the future that I see. It may not happen for 20, 30, 50 years, but it's only a matter of time.
And this is one of your favorite subjects, Bill. Share with our audience your thoughts on this.
Well, there are about 25 specific mechanisms of aging that have been identified, and most of them we can at least mitigate. Chronic inflammation, a lot of creative ways out there to mitigate that problem, and all you need to do is have a blood test for C-reactive protein and see where your inflammation levels are. If they are anywhere near below, or above I should say, the optimal level, do something about it. Don't just let a festering inflammatory problem create atherosclerosis and cancer and Alzheimer's. There's all kind of dietary interventions that can reduce the inflammatory burden.
I have an interesting add to that in showing the puzzle piece that surrounds C-reactive protein. So C-reactive protein is an acute phase protein that's released in response to infection or infectious invaders, microbial invaders. LDL cholesterol protects mice against infection. If you knock out the protein, the LDL receptor, the animals that have very high circulating LDL, it protects them if you give them an injection of bacteria from immediate death. So that suggests that the elevated LDL that goes with aging is related to protecting against infectious burden. So it isn't, for me, it isn't just CRP. It's total cholesterol, which, as you know, increases with age. It's white blood cells, which increase with age, but then the neutrophils go up and your lymphocytes go down. So it's making sure that your white blood cells are not staying constant with time, but you're keeping your neutrophils down and your lymphocytes high to maximally protect you. It's things like fibrinogen, which have been shown to stick in sticky clumps to bacteria to basically probably keep them from going all over the rest of the body. So for me, it isn't just C-reactive protein. It's what's your LDL cholesterol, it's what's your total white blood cell and the differentials, it's fibrinogen. There's a whole panel of things that we can measure to make sure our risk is low.
Well, absolutely, no question about it. And the good news is most of these blood tests, they don't cost a lot of money.
Right.
A couple $100s a year, and for some people, their insurance covers 100% of it. So there's low-cost blood tests that can enable people to identify a pro-inflammatory state and then take action.
What an interesting time in history we're witnessing. What are your plans for the future, Doctor?
I'm going to keep sciencing as much as I can to delay aging as long as I can so that I can live long enough to live as long as I can. That's my plan.
Wonderful thought. Bill, you have the RADFest coming up. Tell our audience about it.
That's the Revolution Against Aging and Death, being held August 4th through 7th in San Diego. We are expecting scientists from around the world to lay out their plans to reverse biological aging in humans. We've gone beyond the animal model. We're now looking at elderly humans seeking to reverse their aging processes in a systemic manner. If you just reverse aging in a brain, that would be terrible because you'd have this young brain and an older body decaying around it. So we're only looking at mechanisms in which systemic reversal of aging processes is induced.
Before we conclude, I understand that you too like science fiction. You saw the movie The Martian.
Right.
Tell me about your thoughts on that.
So in that movie, Matt Damon is stranded on Mars and with limited resources, and he's got to use his scientific background to survive. Because his limited resources, he's going to be dead in 30 days, and he ends up surviving long enough for his crew to come back to save him. So I feel I have the same approach. My time on here on Earth is limited, and I'm going to use what resources I have, the best available scientific published evidence, to science the heck out of aging and get myself to live as long as I can, as healthy as I can, for again, as long as I can. And where that leads or how long that leads, I don't know, but that's the best chance that I can do.
To science the heck out of aging. What a good thought.
That's fantastic.
Bill, a pleasure to have you with us again.
Thank you.
Thank you, sir. Good luck. I'll be right back.